Our task is to review the laws of exponents. Now, if you find this print a bit too small, please refer to your text. So, if m, n, a, and b are real numbers with a greater than 0 and b greater than 0, then these laws apply. So a to the 0 equals 1. An example of that is 2 to the 0 equals 1. A to the first equals a, so 2 to the first equals 2. The exponent 1 is understood. If the product AB is raised to the nth power, then we can rewrite that as a to the nth times b to the nth. But notice, this exponent is outside the parentheses containing the product AB. So, for example, 2 times 3. And we'll stick the exponent 2 outside the parentheses. That equals 2 squared times 3 squared, which equals 4 times 9, which equals 36. A to the negative n equals 1 over a to the n. The base is a, the exponent is negative n. The base is a, the exponent is n. You can change the sign on the exponent as long as you change the location of the base. We only have two locations, numerator and denominator, only two signs, positive and negative. So, for example, 2 to the negative 2 equals 1 over 2 squared. Change the sign on the exponent, change the location of the base, and that equals 1 over 4. Correspondingly, 1 over a to the negative n equals a to the n. For example, 1 over 2 to the negative 2 equals 2 squared. I changed the sign on the exponent, so I moved the base from the denominator to the numerator, and that equals 4. Now, if we have a product of like bases, we can add the exponents. So, for example, 2 squared times 2 cubed equals 2 to the 2 plus 3, which equals 2 to the 5th, which equals 32. Finally, if we have a base raised to a power and that is raised to a subsequent power, then we can rewrite that in terms of the base raised to the product of those two powers. So if we have 2 squared and parentheses raised to the third power, that equals 2 to the 2 times 3, which equals 2 to the 6, which equals 64. Our task now is to simplify and write each of these quotients with a positive exponent. And we'll start with this fellow. And keep in mind, this exponent on the a only applies to the a. It has no impact on the 6. The exponent 7 only applies to the a. It has no impact on the 5. So this equals 6 over 5 a to the 7 times a to the 4th. We change the sign on the exponent, so we change the location of the base. And now this equals 6 over 5 a to the 7 plus 4. We have identical bases, so we add the exponents. And that equals 6 over 5a to the 11th. And that one's done. For this fellow, the exponent 8 only applies to the a, not to the 5. There are no parentheses containing 5a here. Likewise, the exponent 3 only applies to the a, not to the 2. There are no parentheses surrounding the 2a. So now this equals, and the 5 and the 2 are undisturbed. And we have a to the 8th, and I'm going to move this base upstairs, and I can do that as long as I change the sign on the exponent from positive to negative. And now this equals, again, the 5 and the 2 remain as they are, and we have a to the 8 minus 3. We're just adding the exponents because we have like bases. And this equals 5 over 2a to the 5th. And we're done. We've applied the laws of exponents to two quotients and simplified.